Dear learners, welcome to lecture series. Today our topic is moisture content, which is a very fundamental concept in post-harvest technology and also in any field wherever the food is concerned. Okay, so moisture content plays a key role in storage, processing, quality, and safety of foods. Whatever post-harvest operations we perform, and like drying, storage, milling, moisture content is directly concerned with it. So moisture content will directly affect those parameters. Okay. So before going deeper, let us brainstorm three different terms: moisture content, water activity, and pH. So what are all these? So what does all these mean? So though they are related, they are not the same. So today we will mainly focus on moisture content and later we will see how it differs from the other two. So moisture content refers to how much water is present in the food. Water activity tells us how available that water is for the microbial growth. That is the total availability of microbial water content or moisture content for the growth and multiplication of microbes. And pH indicates the acidity or alkalinity. All these together decides the shelf life and safety of the food products. Moisture in food does not exist in just one form. It can be present as free water, which is easily removable, and absorbed water, which is loosely bound, and the water of hydration, which is tightly bound to food molecules. So these are the three different forms of water or moisture content. So the form of water decides how easily it can be removed during the drying. For example, the free water or the surface water, which lies on the surface of any food product, is the first one to get evaporated when it is exposed to high temperature like drying. So moisture content, how is it calculated? So it has a formula where the W represent wet weight and the D represent dry weight. There are two types of weights again for the moisture, which is wet weight and dry weight. This method is commonly used in laboratories and industries to determine the moisture on a percentage basis. So look at the formula. So M, the moisture bed basis, is equal to wet weight minus dry weight divided by wet weight into 100, while the MD, uh, moisture content on dry basis, is equal to wet weight minus dry weight divided by dry weight into 100, where the capital M is moisture content on a percentage basis, W is total weight, which is also called as wet weight, and D is dry weight. What are the importance of moisture content in foods? It is a storage ability, agglomeration in the case of powders, microbial stability, microbiological stability, flow properties, viscosity, the dry matter, concentration or purity, commercial grade in compliance with quality agreements like FSSAI, and nutritional value of the product, legal conformity, statutory regulations governing food. So all these are the importance of moisture contents in food. So it influences all these parameters and even legal standards. That's why moisture content is always specified in food quality regulation. So there are few methods for the moisture determination. They are classified into direct and indirect methods. So these include like oven drying methods, infrared methods, Carl Fisher titrations, and other rapid techniques. While Carl Fisher and oven drying method are the most common methods. And the next one is the mind map where we recall all our points. So here we connect moisture content with its definition, different forms of moisture and its importance, the estimation method and the different methods using uh, instruments or equipments or any direct and indirect methods. So all these contents were discussed in this session. So thank you so much.